Hi guys, I'm Nick from the Coherent Labs team, and in this tutorial I'm going to show a couple of ways that you can use to forward keyboard input to your Coherent UI views. So the two ways that I'm going to show you are basically done very easily, and they are non-intrusive. And the first one is pretty much using macro iterator that uses the input component's bind key function to bind every possible F key to a function, and that's it. And the second one is creating an empty widget, an empty slate widget that is going to be covering the whole screen, and it's going to be taking focus whenever needed. So let's start with the changes. I'm going to show you the changes in the game. So this is not a plugin change. You will need to implement this in your game to have this functionality. So all the changes that we have in our CoUI test FPS game are made in the CoUI test FPS character class. So let's start with the input component bind key method. Here we have this helper class in the CoUI test FPS character. I'm gonna show it to you a bit later. And here is the class that helps us with the widget. Actually, this is the widget itself. So this is the slate widget. And here we have a set Coherent UI input function that is called once after initialization of the scene. And it determines what kind of input are we using. Are we using the input component or the input sync widget? So this is pretty much all of the changes in the header file. Let's check out the CPP file. So what we have here, the input component binder is created just like any other sub-object. After that, we have this setup Coherent UI input function that I talked about. It's called right here only once after initialization, and the default is using the input sync widget. So we're going to be using by default the input sync widget, and here's the implementation of the function. So it's basically if the mode is input component binder, then set the owner of this component. This is a custom method. It just designates this a character class to be the owner of the component. You'll see what I'm talking about in just a second. I'll go into more detail for both methods. So I'm just showing you changes in the game right now. And if we're using the input sync widget, then we just create the widget, assign the owner again to this, and then add it to the viewport and make sure that it's visible. So this is all the code that's actually needed for the widget. And for the input component binder, there is one more call. It's right here in the setup player input component method of a character. And what it says is that if there's a valid owner, this is again a custom method. I'm going to show it to you. So this method just basically tells us if there's an owner set. So if we go back right here, if we're using the input sync widget, then we don't set the owner, and it's going to be invalid here. So we don't go into a crash or something like that. So if we do have a valid owner, and this only happens when we're using the input component binder method for input, then we call this function that is again a custom function, not some virtual function from an U object or something like that, and we pass it the input component. And inside this function we're going to do some bind key calls. So okay, let's start with the implementation of the coherent input component binder. This is the easier method. In general, both methods have some pros and cons, but you have to decide for yourself which suits you better. So the input component has the property that all keystrokes go through that. So regardless of what is focused, you always get those keys. That's not really true with the widget, so you have to do some more work with it to get the right input. But anyway, let's get into more detail in the input component binder. So here's the declaration. It's a U class, and it has this nice macro here. Actually, it's this fkey macro iterator is used by both methods, so it's nothing fancy. It's just a macro that has another argument, that has one argument, which is expected to be another macro, and the argument macro operates over two arguments. And here we have all the arguments set up nicely. So the first argument is the f key. Here we have all the f keys that we need. And the second argument is the key code that Coherent UI expects. The key code that Coherent UI uses is actually the Windows key code. So here we have some definitions for all the key codes that we need. These are actually taken from some Windows header, and they're exactly the same, but we've redefined them, so just in case you don't get some clashes with your own macros or something like that. So this is all the magic right here. Let's get back to the component binder. So this macro here, when passed to the fkey macro iterator, just expands to a series of functions, something like this. I'm gonna just do the coherent on, say, A pressed, and of course there's going to be coherent A released, and another series for backspace, tab, enter, pause, and all of these. So here we declare some functions. These functions are going to be the handlers for each bind key. Let's see what happens in the CPP file. So here are the actual definitions of these functions that we just saw. So the definition actually expands to something like this. I'm gonna copy paste that. So this is the definition. I'm going to do this for the A key again, and it's going to call process key event with f key replaced with the f key, with the actual f key that we passed to the macro. So in this case it's going to be A, and this handler is going to call process key event with e keys A and pressed, and it's going to have another handler for the released method. And this function is the one that actually binds all those callbacks for each key. So here we have another macro iterator function. We call that bind key u functions, and all it does is invoke the bind key method of the input component that we passed. If you remember, this setUpPlayer input component is called in the setUpPlayer input component method of a Coherent UI test FPS character, only if we are using the input component binder input method. If we're using the input sync widget, then this is not called. So here it is. I was just going to show what this expands to. It's really obvious, but I'm just going to write it down. So here it is, input component bind key keys A. I press this. This is this instance, and again this is going to be replaced by coherent on A pressed. So all we did is through some macros and this mapping, we mapped all keys using input component bind key, each press and each release, to a function that calls process key event with the appropriate f key and the state. So let's check out what process key event does. So first of all, owner actor is a weak pointer, so we need to check if it's valid. If it's valid, then we continue down, and here we have this make key event function that's used to create the key event data that you need to pass to the Coherent UI view from the key, from the F key and the event type. It also has an output parameter that to determine if this F key is printable, because in Windows and in Coherent UI, when you press a printable character, basically a character, the sequence of events goes like this: key down, character, and key up. And since Coherent UI uses the same architecture as Windows, not really architecture, but it just uses the same flow of events. So we need to pass the key down, character, and key up. To do this, first we make the key data from the F key and event type, and this function is nothing really fancy. We just we cannot determine right now if this is an auto-repeat keystroke, so we just set it to false. We check if this is a numpad key by just iterating over all numpad keys. Then we check the modifier key state. Again, we check the type. The type is actually determined from the IE pressed or IE released input event enumeration. So we only have key down and key up right now. This if we go into this section, then something went wrong. And here we see another macro iterator. It just says that if the F key that we passed is this F key, actually it compares all the keys because we're iterating, then we set the resulting key code to the key code that we specified right here in the F key macro iterator. So that's pretty much about it. And here is we have a simple method that determines if the keystroke was done on a printable character. So anyway, after we create the key event data, we don't do any focus management. That's up to you. For now, in the demo, what we do is that we pass the input to all the views that are present in the scene. We have this this is a new method. It's going to be in the new version. It just allows you to iterate over all Coherent UI components. So we just start iterating. This is weak pointer collection, so we check if the pointer is valid. Then we get the component, check if there's a view, if there's a valid view, and we send the key event. And there's a little bit more work to do if the character is printable. If the character is printable and the event type is key down, then we temporarily change the key type to character. And as you can see, at the end of the scope, we change it back to key down for the next view. And if this is a character, then we invoke this function getCharacter from keycode, which tries to determine the character from the keycode. And this function is very much imperfect. There's a mapping in the UI4's input manager, I think, that that has this function, but unfortunately in the current release it's not public, but it's in the master branch in GitHub, so it's going to be public in one of the next versions, and we're going to change that. We're going to change this function in favor of the one in UI4, since this actually works only for US keyboards. They're pretty common, but this method only works for English characters and English keyboards. Here's some mapping, but it's not quite correct. So with all this set, let's check out how this works. I'm going to set up a breakpoint. I already have V4 running, so I'm going to set up a breakpoint right here in setup Coherent UI input. So when I hit play, we're going to hit the breakpoint, and as you can see, the mode is using the sync widget, but I'm going to change it so it uses the input component binder, and then I'm going to resume. I've also changed the cube to show Google, so we can see some input. As you can see, we have input, but the annoying thing here is that if you press, for example, A, you're going to start moving, and D, you're going to start moving again. You can see that I'm pressing www and I'm moving. So this is something that you'll need to handle yourself when using the input binder component, input component binder. Okay, so that's pretty much everything that there is about the input component binder. Let's check out the input sync widget. So as we saw earlier, I'm just going to do a little refreshment course here. If we're using the input sync widget, we create this Ask Coherent Input Forward widget, add it to the viewport, and make sure it is visible. The Coherent Input Forward widget is just inherits from Ask Compound widget. We have one argument for the character, which is the owner, and we're saving it in a weak pointer. And here are some overrides for the mouse move, mouse button down, mouse button up, key down, key up, focus changing, and so on and so on. So one important thing that you need to note is that you need to override these functions, supports keyboard focus, and always return true. So let's check out the implementation. Okay, the syntax highlighting is not working, and I'm not sure why, but anyway. So here's the widget. It's actually, this is the widget. As you can see, it's pretty much nothing. It's just a widget that covers the whole screen, and that's it. And after it's constructed, we request the keyboard focus and set it to our widget. We have some handlers that we just leave unhandled. Here in the on mouse button, we have some important logic that I'm going to show you in just a second. Here in the on mouse button up, we return on the handle again. For the on key down, on key up, on key care, we process the event and then return handled. We always return true for the supports keyboard focus. These are not implemented, and this is a function that resembles the one that we saw in the previous method in the input component binder. So let's check out the widget. So all this code, the on mouse button down, is actually written so we can determine when we have clicked over Coherent UI view. So to determine that, we first check all the hot views. If we clicked on a solid pixel. If we haven't, then we do some raycast. Actually, we do just a single raycast and check if we have hit an object that has a Coherent UI component. There's also one more thing about the raycast. For now, we're just raycasting world dynamic objects, so you need to have your objects with Coherent UI components using the world dynamic type. So for example, this is the static actor coherent, and by default it's static actor, but I changed it So it's dynamic. Here you can see the object type and it's world dynamic. If it's not world dynamic, then the raycasting is not going to work. So anyway, if the raycast hits an object that has a Coherent UI component, then again we return handled. This is because below the overlay we have the viewport, and for example in the FPS test and maybe many more examples, and your game maybe, if you click on the viewport, then you enter a mode, an FPS mode, and you start moving around, looking around with the mouse, and actually the viewport takes the focus, and keyboard input doesn't go into your widget. So these callbacks right here, the key down, key up, and key char, are not called if the viewport has focus. So all this code on mouse button down is written for that purpose. So when we click on a Coherent UI component, then the focus is taken by our widget, and it starts receiving these callbacks for the keyboard. And the handlers for the input event is pretty easy. We don't have to do the key down / character checking as we did in the Coherent in the input component binder, because we already have those separated. We have a key down, key up, and key character. So what we do is, again, we don't have any logic for this, but you can save the focused Coherent UI view and maybe send the key event to only that or something else. But for the moment, as you can see from the code, we're just iterating over all components and sending the key event to every single view. Here we have the make key event function, which is similar to the one that we had in the input component binder. As you can see, we just fill in some properties: is auto repeat, caps on, alt down, control down, etc., etc. And here we have a check if we have a key down or a key up event type. Then we cast the input event to the appropriate type, because if it's a character, then it has another type. It's a character event, and if it's a key down or key up, it's a keyboard event. So we check the numpad, we set the key code to the current virtual key code, and that's it about this function. If it's a character, if the type is a character, then we just use the get character method that fCharacter event provides, and that's it. So let's see how this works. I still have my breakpoint. I'm going to disable it for now. We're using the input sync widget by default. So I'm going to go here, and I'm going to press Shift F1 to exit the mouse lock mode. So now if I click over this object or this button here, which is inside the HUD view, I would expect that the viewport will not get focus. And as you can see, that's exactly what happens. And if I start writing, I'm not moving. As you can see, I'm pressing A, and I'm not moving. Also, some selecting with Shift and Control works, so up and down work again, and the keyboard is open. So one thing to look out for is when you click on a layer that is not a Coherent UI component, you see that the viewport got focus, and now I'm moving around and looking around. And if I click, if I press Shift F1 again, and I start typing, or maybe press the arrow keys to scroll, then nothing is happening. That's because when you exit this mode, the focus is not on our widget, and to gain focus you need to click on something that's a Coherent UI component. So for example, I'm going to click on this bar, and then I'm gonna get input. I just pressed backspace and that took me to the previous page, and now I'm writing again, pressing backspace and writing stuff. It's the HUD views actually use a pixel perfect detection, so it's pretty cool. If I click here, nothing happens, but if I click somewhere here, then the viewport takes focus. You can actually check for the focus using the widget reflector by using show focus. You see that when I clicked over this component, the S coherent input forward widget is taking the focus, and when I click around here, oops, well, just gonna click again, the S viewport is taking the focus. So these are the two methods that we devised for forwarding keyboard input to your Coherent UI view. You can choose whichever you like the most, or maybe come up with something else. We also checked the possibilities to add some engine modifications, but it seems that you need to do some very intrusive changes to actually get the input without either a widget or a bind key, and that's why we resorted to these two methods, which are very non-intrusive. You just have to implement it in your game, and you can control everything about the focus with them. All this code is going to be present in the next version of the Coherent UI plugin for UE4, so you don't need to watch the video and copy-paste code or something like that. We're going to provide that to you in the next version. So I just wanted to show you around the system that we made and how it's used, so you can easily change it according to your needs. If you need something special, or maybe not so special. Actually, this is not a very generic system. For example, the forwarding, you can implement your own forwarding to a specific component and not just all of them. It can be enhanced in a million ways. I hope this was helpful, and stay tuned for more tutorials.